let's think about the following graph. R equals to 1 plus cosine theta. Now, one thing to notice is that this graph is periodic with respect to theta, right? So if theta goes to from 0 to 360 degrees, because cosine has the period of 360 degrees, it's going to repeat itself every 360 degrees. So you see that it's going to, once we complete the graph from 0 to 360 degrees, and then we don't have anything more to graph. Okay? So all is good. Okay? So let's try that. So we are going to say we're going to make a table, because that's all we know what to do. If you recall how you drew graphs in the regular XY coordinates for the first time, you're asked to do tables, right? The table is the most basic approach, so we do the tables. All right, so I'll just start with the really basic ones, and then let's try to fill in the other ones. So from 0 to 360 degrees. Now 0, what's cosine of 0? Well, for those who forgot the values of the cosine, let me draw the cosine graph. 360, 180, 90, 270. Cosine starts from 1, 0, negative 1, 0, 1. And it's much better to remember the values of cosine in terms of graphs, because if you just try to memorize the values, it's always confusing, and it doesn't stay in your head that long. Like if you try to memorize the values, after 3 days you're going to forget it. But if you remember the graph, that stays for a long time. So just remember that this is the graph of the cosine. And according to this graph, what's cosine of 0? 1. So if you plug in 0, you get 1 plus 1, which is 2. And if theta is 90 degrees, cosine 90 is, according to here, is 0. So 0 plus 1 is 1. Cosine 180, that's negative 1. It's not negative 1. So you have 1 plus negative 1, which is 0. And at 270, it's 0 again. So 1 plus 0, you get 1. And 360, it's 1. So it's 1 plus 1 is 2. So with the help of this single graph, you now know all the values of cosine, and then this formula just says add 1. So I just added 1, and that's what we get. Okay? Pretty simple. Okay? Okay, now let's plot them. Let's see what it means. Okay, so this means at the ray that's 0 degrees from the x-axis, in other words, the positive x-axis itself, you have to go 2 steps. So you go 1 step, 2 step, right here. That's where the graph should begin. And then at the ray of 90 degrees from the positive x-axis, so this is the 90 degrees, and this is the ray that we're talking about, right? You're supposed to go 1 step. You go 1 step. And then at 180 degrees is 0. So at this ray, it comes down to 0. And then at 270 degrees, which is this angle, right? 270 degrees from the positive x-axis is this. So it's this direction, and you go one step. So you go one step. And at 360 degrees, which is going all the way around, you're coming back to the same spot. Okay? So it looks like the graph is something that's going to connect this to that, to that, to that, to that. Okay? As this, so you have to imagine something like a radar going around. You know how radars work? They use the antennas to sweep 360 degrees, right? So as it sweeps 360 degrees, it's looking at where this thing is, and at 0 degrees there's something like here, and then gradually it changes, and it comes here, and then it comes here, comes here, comes there. So that's the shape that you're going to get eventually. Okay. All right, but right now, I think we need more points to clarify what we're getting, right? So let's do some more. So let's put some more points here. So. Okay, since cosines have values of 1/2 at some point, right? So and that's easy to think. 1/2 is here. 1/2 is here. These are the places where the cosine is either positive 1/2 or negative 1/2. So for those of you who are not so confident with trig functions, let me briefly tell you that the values of cosine at so-called special angles, which are angles that are multiple of 30, 45, and 60 degrees, always we follow the pattern of these values, these three values. They all look the same, and it's easy to remember. It's easy as 1, 2, 3. 1, 2, 3. So it just comes in these three varieties: small, medium, large. And this, because this is the smallest, square root of 1 is 1, so I just write 1/2. We're looking for special angles between 0 to 90 degrees, which is 30, 45, and 60. And because this is the smallest, this must be same as that value. Okay, so that's how I located this point here. Okay? And among the three special angles, this is the one that I look for. That's the negative 1/2. That's the negative 1/2. That's the positive 1/2. Okay? And when you do this, when you pick this 1/2 thingy, you should always be aware of these other special angles. Okay. All right. So here, this is what angle is that? So 30, 45, 60. This is 60 degrees, right? What's this? Out of the three, it's the first one, so it's like 30 away from the 90 degrees, right? So what is it? 120 degrees. And then what about this one? This is like close to 270, so it must be 240. And this one, right after 270, 300. Good. So those are the angles that I'm going to use. I'm going to use 60 degrees, 120 degrees, 240 degrees, and 300 degrees. And at those points, at these 2 points, cosine is positive 1/2. At these 2 points, cosine is negative 1/2. Okay? Just reading from the graph. Okay, so let's do that. 1 plus 1/2 is 3/2. Right? Okay. At 120, it's 1 minus 1/2. Right? What's that? Just 1/2, right? 1 minus 1/2 is 1/2. And again, 1 minus 1/2. Okay, so and these are like 1.5, 0.5. So those are the quantities. So let's try to use it. Okay. So at 60 degrees, which is like that, this is 1, and 1.5 will be slightly bigger than this one thing here. So I guess something like here. You can use your judgment to kind of maybe a little bit more here. How's that? It kind of makes sense, right? So see what I did? This is 1. 3/2 is 1.5, so it must be 1.5 more, so I say this. That's how I plotted that point. And then over here at 120 degrees, this is 1, and we're going to go half of it, so it's more like here. And then, because the previous points kind of have this symmetry, you would also expect the other points to have symmetry, and that's exactly what happened. So at 240 degrees, it's here. At 1/2, it's exactly the same length as this. At 300, it's right here. And 1.5 is again somewhere here. So we connect these points, and that's what we get. Okay. And if you plot further more and more points, you can see that it's indeed closer and closer to this shape. However, let me put some minor details in this picture. Okay. So first thing is, as the radar is sweeping, it hits 0 when it's 180 degrees, right? So it goes like this. It's shrinking and shrinking and shrinking, and the moment when it hits 0 is when it's exactly 180 degrees. So what happens is that whenever you have a 0 for an angle, you might think, well, this angle doesn't do anything to the graph because whatever the angle is, 0 is just 0. It's always the origin, right? You might think that this doesn't have any meaning, but it does carry some meaning. The meaning that this has is that when it hits the origin, the angle that it's hitting the 0 point should be this 180 degrees. Okay, so that's actually pretty important. So I should say the angle which the curve hits the origin is 180 degrees. So that's how you should. The angle hits 180 degrees. Okay? So it's hitting 180. So that's what you have. And another thing is, see, other than this point, this graph is, this thing is differentiable, right? Meaning that the curves doesn't change abruptly. If it changes abruptly, then you can't define the tangent line, and that causes a problem. The only place that's not true is when you have the origin. So other than the origin, the graph should be changing smoothly. So even here, you can't just say this and that. Okay? It has to be like this, so that the tangent line is a vertical line. We know that it has to be a vertical line because it has this symmetry. Okay? So that should be the graph, just like that. And this graph has a name. It looks like what? It's sort of like the heart sideways, right? It's like the heart sideways. So the name for this curve is cardioid. I mean, when you work out, you say cardio, meaning hard work out, right? So that's the name. And then I would like to add that there is one place where you do get to see this. That's when you go to karaoke and you hold a mic. Wait for a minute and look at the mic, and it says cardioid mic. Now, why does it say that? That's because the mic catches the noise in a somewhat directional way. So if the microphone is like that, then it will catch more volume from something that's spoken in front of it. And it's not going to catch much noise that's behind it. And the way its sensitivity, the sensitivity of the mic with respect to the direction of the mic held, it has exactly this graph. That's why it's called a cardioid mic. I don't know the reason why it's like that, but they manufacture it that way. As opposed to cardioid, there are some mics that are omni mics, which is like circle all the way. It has the same sensitivity all around. So people use omni mics if they have to record the crowd noise and stuff like that. But if you have to record a single singer singing, you don't want the other noise to be crowding the voice. So you want to use the cardioid mic. So that's something to see next time you hold a mic. Usually they have this pattern on the mic. So if you ever wondered what this pattern was, it exactly means that it's following the cardioid curve pattern.